Hello everyone. My name is Mike. Kia ora. I'm from New Zealand. This is my friend Ian. He's a control engineer. Let's see what is he doing. Hey Ian, what are you doing here?
How's it going, Mike?
Good.
Yes.
This looks pretty fancy. What does this do? Can you explain to me?
Right. We got a customer coming tomorrow to have a look at the demo palletizing station. And
Nice.
we've also been given a sample test boxes from the customer. And
Cool.
I'm just making the tweaks to be able to handle this particular shapes and then demonstrate it to the customer tomorrow. And also the customer is kind of interested to see the whole thing in action.
Is it working so far?
Oh yeah, it's almost there.
Oh, okay.
Yeah.
Nice. Okay.
And also the customer is keen to see what hardware is actually involved in it, and also how much effort is actually to set up the palletizing pattern. I think
Cool.
he's quite keen to get his maintenance people to be able to do some simple troubleshooting, or if some product
nice.
size or pallet changes a little bit. So I'm going to.
I can't wait to show. Can you just show me every single component on this fancy machine?
Yeah, right. So let's just get a very basic a run through of this. So the palletizing station normally has a robot. So this is a collaborative robot. What we have is a 6 kg payload with 1.2 meter reach. That's your working radius.
Oh,
And the box is about 3 kg weight.
Oh.
So the 6 kg is more than enough. So depending on what weight you are handling, so you can go for a bigger one. Sometimes
okay.
it will go up to 20 or 25 kg.
Question. So when you say 6 kg payload,
Yeah.
so what happens if the box is more than 6 kg?
So in that case, we can choose a bigger robot. So the next one may be 10 kg or 12 kg or
Okay, nice. Carry on. Thanks.
And then on the Cobot, as you can see, this is a custom-made vacuum head with 4 suction cups on it. So this has been specially designed to suit the product shape. And just come over here, you see here, the grippers has been made with a slot, so we can actually adjust the vacuum positions slightly on the go. So it's very kind of economical solutions. Okay, and to use the vacuum cups, there are a few other pneumatic fittings we need to introduce as well. So this is the main air inlet. So this is the air pressure regulator. So that can ensure the correct amount of air pressure is actually fed into the system. So these two slim electronic kind of thing is a vacuum switch. So what that does, while the robot is trying to pick apart, that turns on, and then that enables the air pressure towards the vacuum cups, and then that just picks up the part. And these two sensors here, they are the vacuum pressure sensors. So what we do use them for is actually constantly monitoring the pressure build up between the cups and the products. So when there's a sufficient pressure present, we will actually turn off the air supply from the vacuum switch to the vacuum cups. So the air compressor doesn't have to run all the time. It's kind of like a energy saving mode. Yes.
It's kind of like a valve, right? Shuts off and
sort of
opens.
valve,
Yes.
But this is more for the energy saving purpose.
Oh, okay. Cool.
Of course, you're gonna have to have a stand.
Yep.
Yeah, so the customer particularly wanted this kind of a stainless steel kind of like a shape. Yeah, sometimes we can even mount the robot onto the case.
Cool.
Okay. And next thing, we will have a look at the in-feed station. So what is also referred to as a pallet pickup station. So that's where the robot picks up the products. Yeah. So most of the customers or production environments, they'll have their own sort of like a conveyor where they're already transferring the product from upstream to the downstream. So for this purpose here, the demonstration, we just have a little section of unpowered gravitational kind of like a conveyor. And then we'll just manually place the products here, and then the products will just slide to the bottom. for the demonstration purpose.
Yeah, that's more than enough.
Yeah, and then here you see there's a photo eye sensor. So that is used to detect the presence of the products here.
Ah,
And then on the other side, we have another side pushing cylinder. So what that does is, once we detect the product is present here at the end, the program will actually push out the cylinder,
yes, yes.
and the product will be pushed right to the bottom right corner. So the product will be at the same position every time, and then makes it reliable for the robot to pick it up.
Good.
Okay. And the next thing we're gonna briefly go through tomorrow will be the outfit pallet configuration. So what you see here is a single pallet.
Yes.
But the customer is going to implement the two pallet configuration.
Oh,
The reason for that is actually to increase their efficiency and uptime. So what that means is, if the robot is picking up from pallet 1 here,
yeah.
and if pallet 2 was already full, so the operator can go and unload it and then load empty ones back in, so the robot can actually switch in between without having to wait for available pallet. So it's really to improve the efficiency, and it's not really a whole lot more setup effort.
So this robot arm will never stop, or will just keep going, keep going.
If the coordination between the operator and the production is actually is a plan of ours, so this will be on as a full smoke.
Cool.
Yeah.
Hey Ian, is the programming part is really difficult? For example, if someone worked in their factory, they don't have any programming background, is it really gonna work for them? Can you just talk a little bit more about how do you set it up?
Yes, programming is actually quite straightforward, a lot simpler than what most people actually thinks. Most of the robots, they do come with some sort of like a built-in palletizing package.
Yes.
Simplifies the whole thing a lot. So for example, looking at this pallet here, each layer's got a pattern like 3x3. So the robot needs to go and place onto every single jumper point, right?
Yep.
Yeah. But what the software can do is, we can just choose one of the corner ones.
Yep.
Say for example, this is the corner one, and then we take that one as the reference point.
Uh,
So we just have to teach one reference position to the robot,
yes.
and then everything else, the other 8 positions, can be offset to the original reference point in the X and the Y direction.
Yeah.
And then also, if I want to go to a different layer, so we can even apply the height offset, which will be just the height of the box.
So
So literally, you just need to teach.
is that Z direction?
Yes.
Okay,
So
okay.
literally, you only need to teach one position. on
So
the pallet.
which is the starting point?
Normally it will be the bottom layer, and you choose a corner. Normally.
Yeah. Okay. Depends on their site, right?
Yes.
Okay.
So this is actually all modified to suit the product size, and then it's kind of ready to go now.
Oh, can't wait. Can you just show me? Is it really working? I wanna just have a look, see if it's really gonna work.
Okay, cool. I'm just gonna hook up the ear, so just.
Yep. Yeah, he's gonna show us. That's really working.
Yeah. So let's. We've only got 18 boxes, but the customer is looking into actually do it up a pallet of like 6 layers. Yeah. But for demonstration purpose, this is kind of like enough to prove to show the concepts.
Cool, cool, cool. So one last question.
Yeah.
How much does it really cost to actually build this demo station? Just roughly a ball figure?
So yeah, very roughly, the Cobot 6 kg is about 25 grand.
New Zealand dollars?
Yeah, New Zealand dollars.
Oh, okay, cool.
And then the stand is about $1,000, and some pneumatic accessories, and would even put a docking station, and a bit of an integration to the existing conveyor and all the sensors, controller, plus a bit of a setup fee. So we're probably looking at around $50,000 as a package to start with.
Cool.
And the programming effort is actually really minimum. So it took me, well, we already had the previous demo and then
Yes.
just changed the product size to a different pattern, different height. It took me probably about 1 hour-ish.
Wow, that's pretty quick.
So yeah, it's a pretty simple and cost-effective kind of like a package, and it's a very portable.
Okay. Cool. Hopefully, good luck tomorrow.
Right,
I mean-
thanks. Yeah, the customer's they're gonna love it. Yeah.
Sure. Okay.
Right.
Thanks. Bye.